Hello. In this video, we're going to look at how to compute a factorial ANOVA. In this case, it's all between subjects in a 2x3 design. So for starters, we've got sort of just a lot of preliminary code to set up the example we're going to be working with. As always, we're going to load the packages we need to work with. Today it's quite a lot. And then read in the data file, and then here we're just selecting the columns and doing a little bit of tidying. And then here, building off of the example we did earlier for a one-way ANOVA, this is just reverse scoring the necessary columns and computing them into a single index of what's going to be our dependent variable today, a variable called recalled well-being. And then finally, we need to take one of our independent variables and tell it explicitly the order that we want the levels to be in. So sort of a lot of boring cleanup work to start here, but when we run all of this, we'll be in good shape to start our example. So let's start by just taking a look at the variables we're going to be working with. As I mentioned, this is a 2x3 factorial design. So here we're interested in predicting people's level of well-being during an event that they recalled. And that event varied based on random assignment to one of three conditions. And this is familiar. This is the independent variable we used last time when we were looking at a one-way ANOVA. So that's this condition variable here, where people are randomly assigned to recall some control event, or a time they were included, or a time they were phubbed or ignored while their conversation partner was looking at their phone instead of talking to them. Cool, so that's familiar. What's new here is now we have a second factor, or another independent variable, and that is called anchor here. So prior to this, in an unrelated task, people were asked to estimate the number of Skittles in a bag, and half of them were anchored to the number 40, and the other half were anchored to the number 80. So the question that we are able to answer with these variables here is, overall, does condition matter? Overall, does anchor matter? And then in particular, is there an interactive effect between condition and anchor? Does the way that condition matter depend on the anchor variable, or vice versa? That would be a job for a two-way factorial ANOVA. So let's take a look at how to actually go through the steps of running that. Now, for starters, we always want to be able to look at our descriptive statistics, the means and standard deviations. And this code here groups by each of our independent variables and then computes the mean, standard deviation, and the number in each condition. And so when we look at this table, conveniently it's ordered by each of the conditions. So the first three rows show the statistics for each of the conditions among those who were assigned to the anchor of 40. So we have control, inclusion, and phubbing for each of the 40 groups, and the associated mean, standard deviation, and sample size for each. You can see the sample sizes here are ridiculously small. As always, this is an overly simplified example to illustrate the steps. I can't imagine a typical time when you do ANOVAs with 7 people per condition, but you get this as an example. Then, of course, we have the same information for the 80 condition. All right, that's good to have the numbers, but of course we need a graph, and this gives us a good picture of what we're working at here. The key thing I want you to notice is that in this graph, because we are doing a 2x2 ANOVA, or I'm sorry, a 2x3 ANOVA, it's going to be important for us to separate the pattern of results out by the different levels of the factor we're looking at. And the way I've done that here is by adding a facet to show us separately the results for the three conditions in one of the anchor conditions versus the other anchor condition. And I did that with facet wrap here. And when you run this, we get our three experimental conditions broken down by whether they're in the anchor equals 40 group or the anchor equals 80 group. And like last time, you can see condition is having this very massive effect. And we can visually approximate maybe it's a little bigger of an effect in the 40 condition versus the 80 condition, or maybe that's just sampling error. Well, that's what we need to run the ANOVA to formally test. So to do that, we're going to use code that's nearly identical to what we did last time for the one-way ANOVA. Again, we're going to give it an ID variable, just identifying that each row is a participant. And the dependent variable is, of course, the name of the dependent variable, which is recalled well-being here. And then our two factors both go in this between argument. Condition, just like last time, but now we're adding a factor called anchor. And condition has 3 levels, anchor has 2 levels. So altogether, this is going to give us a 2x3 ANOVA. And then finally, to get that effect size here, we want to add ES equals PES, which stands for partial eta squared. We run this, and we get our ANOVA. We have 1 row for each of the effects that we care about in our ANOVA, so that would be the main effect of condition up here on the top row, the main effect of anchor on the second row, and then the interaction between condition and anchor on the third row. And so to interpret this, we can see our condition factor has 2 degrees of freedom. That makes sense because it has 3 levels overall. And we have the associated statistics. We have a very strong F statistic. Our partial eta squared is massive, explaining over 50% of the variance with a very small p-value. Cool. We can see anchor has a very small F statistic, explains very little variance, and has a non-significant p-value of 0.419. Cool. And then finally, looking at the interaction effect, we also have no evidence here that there's an interaction. In other words, in this data set, there's not any real reason to believe that the effective condition depends on anchor. So although the effective condition is very strong overall, it appears to be not detectably stronger in the 40 condition versus the 80 condition. It's possible, of course, that a bigger, better study could detect such an interaction effect, but for now, we have no evidence that there is an interaction effect. So this would be a non-significant interaction test. So there you have it. That is how to conduct the 2x2 ANOVA. Now, in the next video, we will look at how to conduct simple effects of particular comparisons within levels of another factor. Now, very often you'd want to do that when there is an interaction, but sometimes you want to do it either way. So in the next video, we'll look at how to do those simple effects.